Okay, homework 1, real numbers and properties. So we're going to start with number 1. The directions for this set of problems are name all sets to which each real number belongs. So those are these sets down here. So it's nice that we've got this little graphic to reference while we're looking at number 1. So the number is -5/3. Okay, so the first distinction that we have to make for each of these numbers is it irrational or is it rational? It can only be one, it's always one of the two, and it's never both. Rational and irrational because they're complete opposites of each other. So rational means that you can write it in a fraction form. The decimal form will either terminate or it will repeat. So you can see that this value, it's written in a fraction form, like a over b, like we talked about in class. So this one's definitely rational. So our symbol for rational is that double blocked R. Okay, so it's not irrational. If it's irrational, that's all it is. So you would just write irrational and then you would be done. So what we do is we determine if it's rational and then we work our way down to the most specific set. If it's ever not one of these, then it can't be any of the ones inside. Okay, so we start with it being rational and we start to work our way down. So it is rational. An integer, those are -3, -2, -1, 0, 1, 2, and 3. The way I like to remember with these ones are all technically fractions, but the denominator would always be 1. All right, so this one is not an integer. Integers are basically positive and negative whole numbers, and this is not a whole number, so that just means that it's rational, and that's it. And so we stop right there for number 1. All right, so our next set, we are going to look in number 7. We're not going to do all of number 7. We're just going to do letter A. So whenever something gives you a square root, don't get tricked by the fact that it's a square root. Just because it has that radical sign, it does not automatically make it an irrational number. What you want to make sure is if it's something that you can simplify, that you do that you simplify it up. So the square root of 196 actually comes out evenly. It is 14. So with that negative sign out front, that just means that the negative square root of 196 would be -14. All right, so we can write that out, and we would have -14, and then just using that number, we can figure out which of the sets it's going to fit into. So this is actually a -14. All right, so we start irrational or rational. It's definitely rational because it can be written as a fraction a over b. So the a over b would be -14 over 1. So it's definitely rational. We move our way a little bit further to see if it can fall into any of the subcategories of rational numbers. And so we've got, is it an integer? Yes, it is an integer, because remember that was the set -3, -2, -1, 0, 1, 2, 3, etc. So it definitely falls in this set. Then we move to the next set, which is whole numbers. Whole numbers do not include the negatives. So whole numbers, as we have them written, are just 0, 1, 2, 3, 4, etc. So since this is a negative number, it does count as an integer, but it does not count as a whole number. So the way you guys are going to set up your homework is you are just going to write each letter in the furthest subcategory in which it falls. All right, so that is letter A. We are going to do number 8 in our next set. And in this set, you guys are naming the properties that are illustrated by each equation. So this was on the second set of your notes where you guys had the commutative, associative, identity, inverse, and distributive property. Other than the distributive property, for each one you should be specifying whether it's an addition example or a multiplication example. All right, so this one, you can see, just based on the way it's written, it's definitely an addition example. So commutative means that the order doesn't matter. So that's not really what we're dealing with here. The commutative property says a plus b is the same as b plus a, and that's not really this. The associative property says that you can group the numbers however you want and add different sets of them together first. That's not really this one either. The identity property says if you add 0 to a number, you get the same number that you started with. That's not this either. The next is the inverse property. The inverse property says if you add a number to its opposite, you get 0. And no, I'm just specifically talking about the addition ones here since we recognize that there was an addition sign. So it's obviously not a multiplication example. So it is the one that I just was talking about. That's the inverse property, which again says that when you add a number to its opposite, you end up getting 0. So here's a number, here's its opposite. So this is the inverse property, and it is the inverse property of addition. to be specific. All right, and one last set of examples here. We are talking about the closure of numbers for this last set. So this one says that natural numbers are closed under division. Okay, so what that means is if you take a natural number and divide it by another natural number, what you get is a natural number as well. This is definitely false. If you take just about anything and divide it by a different natural number, the only exception is dividing by 1. So we are going to say that this is false. And a counterexample would be just about any division that's not dividing by 1. All right, so the counterexample, let's say you take, 2, which is a natural number, and you divide it by 3, which is also a natural number. 2/3 is not a natural number. So that means that the natural numbers are not closed under division. In other words, if you divide a natural number by a natural number, it's no longer necessarily a natural number. All right, those are your pointers for homework number 1.